Let's start with the first question. For harder X-rays, obviously if the X-ray is hard, it has to penetrate through a large distance, so its energy comma frequency should be high. So its frequency should be higher and energy should be higher. Cutoff wavelength of X-ray coming from a Coolidge tube depends only on the accelerating voltage, not on the material, neither on the spacing or the temperature of the filament. So the correct answer is B only. Mark the correct statement. An atom with a vacancy has a smaller energy than the neutral atom. The statement is wrong. The K X-rays is emitted when a hole makes a jump from K shell to some other shell. Obviously, the electron is coming back to K shell, so the hole has to jump from that shell from which the electron is coming from K shell. Okay, so this statement is correct. The wavelength of K X-rays is smaller than the wavelength of L X-rays of the same material. This statement is also correct. So we can read the next one. The wavelength of K alpha X-rays is smaller than the wavelength of K beta. No, this statement is wrong. Wavelength of K alpha is greater than K beta. Yeah, it's greater than K beta for the same material. You can look at the diagrams also. These are K gamma, K beta and K alpha. As K alpha corresponds to a transition having maximum energy, transition having from n equal to 1 to 2, so its energy will be less in comparison to the transition which is taking place for gamma. K gamma is from 1 is to 3, so this energy will be more, so wavelength will be small as compared to this. And comparing between the two shells, we can say that option B, which is how a hole moves from shell 1 or shell K to any higher shell, or an electron jumps from higher shell to K shell, forms the X-rays, and the wavelength of K alpha is smaller than L. Obviously, they have to be smaller because the K series has more energy in comparison to L series. Okay. You can look at the diagram. In the next question, for a given material, the energy and wavelength of characteristic X-rays satisfy. As I have already mentioned that in this graph, energy of K alpha is less than energy of K beta is less than energy of K gamma. So K gamma has the most energetic wavelength, so it will be smallest in value of wavelength. Okay, so but as we increase the wavelength, energy decreases. So we can add the options. Energy of K alpha is greater than K beta. No, this is a wrong statement. Energy of uh, K alpha is least in comparison to L and M. This is also a wrong statement. Lambda of K alpha is greater than lambda of K beta, lambda of K gamma. This is a valid statement. And lambda of M alpha will be far greater than lambda. This is also a valid statement. So C and D are the only two valid statement here. In the next question, the potential difference is increased as the result. What will happen to the emitted radiation? So by increasing the potential difference, minimum wavelength will decrease and intensity will remain unchanged, because the intensity depends on uh, the current in the heating filament. Okay, so intensity will remain same and minimum wavelength will decrease. In the next question, when an electron strikes the target in a Coolidge tube, its entire energy may be converted to photon or may not be converted to photon. So as I said, it may be converted into a photon, or it may be converted into heat also. And the next question, X-ray is incident on a material, it exerts force on it, transfer energy to it, transfer momentum to it, transfer impulse to it. Obviously, C and D are the same things. Transferring momentum is transferring impulse, and it obviously will exert force because it will transfer momentum, and it will also transfer energy because the material will absorb some of the photons, so it will also absorb energy or transfer energy to the material. In the next question, consider a photon of continuous X-ray, a photon of characteristic X-ray of the same wavelength. Which of the following are different for two photons? Energy, frequency, penetrated. Okay, as the wavelength are same, they will have same frequency and energy and penetrating power. And but just the method is different. One is coming from the transition, which is continuous spectrum, and another is coming from the loss of kinetic energy of hitting electron, which is the continuous spectrum. Okay, so the method of their creation is different and all other factors will be same because they have same wavelength.